This episode of the HVAC School Podcast is made possible by our great partners, Carrier, Mitsubishi Electric Cooling and Heating, which you can find more information about by going to MitsubishiComfort.com, the UEI Hub Smart Kit with the Hub 2 kit, which is the air probes, the Hub 4 kit, which is the refrigerant probes and clamps, and the Hub 6 kit, which is all of them together. Great new kit from UEI made by Arbiter, my friend Adolfo Wirtz, who was on the podcast a couple episodes back. Encourage you to listen to that. That is out now. Find out all the great features and benefits, including the charging tee that's built right into the probes. Also want to thank Refrigeration Technologies. Refrigeration Technologies can be found at refrigtech.com, refrigtech.com. One product that I was quite surprised by recently was looking up the Viper Heavy Duty Cleaner. That can be used for evaporators and condensers. It is a balanced pH cleaner, so it's safe to use. You can actually even dilute it down to 20-1 and use it as a no-rinse cleaner. I was shocked to find out how reasonably priced it was. It was actually half the price of the cleaner that we were using, and it's a foaming cleaner. My techs love it. Also want to thank AirOasis for their partnership on the podcast, makers of the AirOasis Bipolar and Nano air purification products. Great products. You can find out more about AirOasis by going to airoasis.com. And as always, I want to thank TruTech Tools, trutech.tools.com. You can get a great discount on any of the tools at trutech.tools.com by using the offer code GetSchooled. And one of those great tools I would encourage you to look at is RetroTech blower doors. If you are not in the blower door business yet, I bet you will be someday. It's a fantastic tool for finding out how tight or loose a space is, which is sort of an important part of doing a good solid load calculation on an existing structure, as well as properly testing new structures. All in all, thank you to the people who make HVAC School possible. Most of all, you, by listening, because that's the reason why people want to partner with me, is because you listen, and I appreciate you most of all.
Meet Zoomlock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how Zoomlock can help you be more efficient and productive. Visit Zoomlock.com for more information.
Allow me to introduce the guy who actually says, actually, after every word, actually, Brian Orr.
I don't appreciate that pretend Christopher Walken. I actually say actually a lot more than you actually ever know because I edit out so many of my actuallys. It's funny when you talk a lot, whether it's in front of people or on a podcast or in videos, that just certain words start to come out all the time. And one of mine is actually. At least it's not like. Hey, thanks for joining us today on the HVAC School Podcast, the podcast that helps you remember some things that you forgot about the HVAC trade as you've been out there working, and maybe helps you remember some things you forgot to know in the first place. And today we're talking about air filters. We are talking about air filters with the one of the elder statesmen. I don't want to say elder statesman. That's going to make him sound old, but he's not an old guy, but he's just been around forever in the Orlando market. His name's Lee Andrews, the owner of Andrews Filters. And Lee knows a lot about filters. He's passionate about filters. And it's funny because so many new indoor air quality products that come out, and a lot of them very good products, but we start to forget sometimes about how important just basic air filters are and thinking about air filters and choosing them well. And so Lee goes over some things that you probably don't know about air filters and some things that often get hidden in the specifications of many air filters. And so here we go. Lee Andrews talking air filters. All right, so today I'm actually off-site. I usually am recording in the HVAC School Kalos offices, but today I'm actually at a kind of a HVAC institution here in Orlando, which is Andrews Filters, and I'm sitting here with the one, the only Lee Andrews. So thanks for sitting down with me, Lee.
Hey, I appreciate you coming in and talking to me. I hope we can help some people today, maybe understand about air filtration and things related a little bit better.
Yep, and it's interesting because right off the bat, it's such a misunderstood thing. It's such a core piece of what we do every day. And there's this big push into IAQ, but a lot of us don't back up, me included, and take the time to think about air filters and air filtration. And I came in, I don't know, it's probably been a month ago or so, a few weeks ago at least, and Lee gave me a master's course on air filtration. And I thought, this will make a great podcast. So let's sit down and do that. But before we do that, if you wouldn't mind just telling us just a little bit about Andrews Filters and a little bit about you.
My brother and I, Mark Andrews, We were second generation owners. Our father actually started the company 47 years ago. And we do a little bit of manufacturing and represent some global companies. I've personally been in the business for about 35 years. My resume a little bit. I've helped out with like the green lodging program for Florida for hotels, some sustainability things like that. Some of the things that we do everything from hotels to NASA to hospitals, anything HVAC related that you can imagine. That's what we do. So
as I was sitting in the lobby, I was overhearing a conversation, and it sounds like you sell to a very famous mouse as well. So I'm sure that's a good size account.
Yeah, we do a lot of course, here in Orlando, we have a lot of theme parks, probably one of the most visited places on earth. That's one thing that, back to the green lodging thing that was really big, is Florida is very tourist oriented. So they wanted to make sure that our hotels were clean and things like that. So we actually wrote specifications for green lodging program for the filter side, which required a much better filter, MERV 8, MERV 8A filter that would actually even go into the guest rooms. So we're trying to keep even the guests a little bit happier in that. And trust me, when they go into rooms, a lot of people go in and they look at filters. They look in the grill. I'm sure they do. I do.
Right. I know I do. I've actually said this a couple times in the podcast. I'm not good about changing the filter in my house, but it's the first thing I do when I go into a hotel or a vacation house where we're staying is check the filter. How's the maintenance on this thing? So, of course, that's probably just my judgmental AC technician side as well, just wanting to make sure everybody else is doing their job. So let's start with a really common thing that I'm sure a lot of people don't have any reference for. So when you say MERV, what is MERV in the first place?
Well, we're not talking about Merv Griffin, people that are old enough to remember him. MERV is basically a standard that ASHRAE, the American Society Heating, Refrigeration, Air Conditioning Engineers, long acronym.
Yeah, mouthful.
Yeah, that actually they write all the standards for anything HVAC related that needs to be testing and things like that. And air filtration is one of those. And so to start out a little bit in that, originally there was what we called the 52.1 dust spot test. So
I remember that one, yeah.
Way back in the day, if you remember, say a pleated filter might be a 30% efficient filter, and then you might have bag or box filters, final filters that might be 65%, 85%, or 95%. So now, to go back, the way that was tested was they actually put paper targets in front of, I guess, this filter or behind the filter. Whatever got through the filter, they basically shined light on this little paper target to tell you how much particulate got through. It was a little bit rudimentary, and MERV was a step up in the 90s when they started using particle counters, air measuring devices, different things. And it's a way to test filters where we can look at certain micron levels. So basically what we do is there's a parameter where they look at small, medium, large particles. They basically put those together and then give you a rating on those size particles. So that is basically going to give you your efficiency. Basically, as you go up in number, say MERV 6, MERV 7, MERV 8, the filter is more efficient and stops smaller, finer particles.
This is sort of like when people ask what all goes into doing a SEER rating on a piece of equipment. It's like to calculate EER, it's a very basic, but once you go into SEER, now it's not just a matter of how they come up with it, it's all the different conditions. And so are they sort of averaging the different sizes? When they're doing this calculation, they're saying here's the capture rate at larger particle sizes, here's the capture rate at medium, and here's the capture rate at small?
Most of the particles in the range are 20 micron sized particles and less. Most of the particles in the air are less than 1 micron. And a cubic meter of air typically, in typical atmospheric conditions, even indoors, it could be average about 1 billion particles, 1 billion particles.
Oh, wow.
So that can freak you out a little bit because you think, oh my gosh, all the stuff we're breathing. Well, if you see the sun shining in your family room, and you see the light reflecting off the dust particles and all, everything you're looking at is about 10 micron and larger, because that's what the human eye can see down to. In that billion cubic meter of air, typically that's 1 billion particles, 99% of them are going to be less than 1 micron in size. The majority of those are going to be between 0.2 and 0.6 micron size. So the average is around 0.4 micron, most of the particulate in the air. The problem with a lot of filters, even pleated filters and things that we're looking at 0.4 micron, typically they stop about anywhere from about 5 to 15% of the particulate. So the rest of it's left in the air. Things like asbestos fibers, one reason why they're so dangerous, well, there's two ranges. One is the size of the particle is 0.3 micron in size.
Okay.
The size of a lot of the pores in your lungs are that size. So they get lodged in the pores of your lungs, and therefore they're carcinogen, and that's why they're cancer causing.
Right.
So there some things like that are a big effect. The filter industry is going that way. We'll probably talk about that a little bit later in the cast, but we're looking at smaller and smaller stuff and the effects and the health effects. Filters originally were, we want to keep this coil clean. We want to keep the blowers clean. That's great. All that's evolved into, it's leaning more and more and more now towards human health. So that's sort of our goal of what we're starting to get to, especially more people on Earth, the more polluted that the Earth becomes, and indoors, people spending time indoors.
So the two sort of objectives of air filtration are, one, like you mentioned, protect the equipment. So it's got to do a good enough job that it's going to keep stuff from growing on your evaporator coil and getting in your ductwork. There's that, which sometimes we even struggle with that. And then number two is that you want to catch the particles that could potentially cause health problems. And as we get into this sort of indoor air quality conscious, health conscious environment, and like you mentioned, as you increase pollutants in the air and maybe increase the number of people who are living in cities and the more time they're spending inside their homes, all these different factors that play into that, and just also the awareness of it. But then there's the concern that most technicians have, which is, okay, if you've been around the field long enough, you remember the ages of, I'm not going to name any specific brands, but when I was in the field, we called them the cherry bomb filters. Nothing gets through, including air. And so we're also concerned that we have filters that don't have too much resistance to airflow as well. So can you speak to that a little bit and sort of the relationship between those factors?
Filter technology has really changed a lot over the years. And at one time, that was a big issue. One thing that you really want to look at is surface area. So naturally, the more surface area you have, you're going to have more room to blow air through. Think of sipping something through a coffee straw versus a big gulp straw. You're going to have a lot more airflow when you have more media in the filter. Some of the filters that we have now that are available in high efficiency products, so this would be like box filters and things, a 24 by 24 inch by 12 inch deep filter has 200 square feet of media in it. This is a filter that will actually last 2 to 4 years in typical applications. And the nice thing about it is so much media in there. The initial pressure drop is lower than a standard MERV 8 pleat. And this is on a MERV 14 95% type filter.
Okay, wow.
So we can take really good filtration now and apply it and even have a lower pressure drop and do twice as good. And when we're talking about MERV 14 filters, we're talking about filters that take out 60 to 75% of the 0.4 microns, as opposed to a regular pleat is anywhere from about 5 to 12, again, 15, somewhere in there.
Right. And so a regular pleat that most of us are probably used to. I mean, there's still a lot of the old hog hair filters out there and metal mesh filters and all kinds of total garbage that we know really doesn't catch anything. I mean, those of us in the field recognize that. But you take a typical pleated air filter that you buy from your local carrier distributor or whatever, it's going to say MERV 8 on it. And that's what we're used to seeing. And so I'm teeing this up for you, of course, but isn't that the way to go? Just buy a typical MERV 8 air filter and slap it in there. What's wrong with that?
In the 90s, when MERV came along and it was useful, some things that we were noticing in the field were some filters actually dropping in efficiency over time. So filters that were purchased as, let's say, a MERV 8 filter, we would go back and test this filter a few weeks or whatever, month or two later, and it had dropped to a MERV 5 or 6. Our industry started doing some looking at this and found out that some of the things that happens is a lot of what we call coarse fiber medias or large diameter fiber medias. In other words, the thickness of the fiber is a little larger in size.
Right.
And typically these are synthetic polyester type medias. What was happening is these filters come because it's a plastic fiber, either with a little bit of an inherent electrostatic charge on them, or they would have a charge imposed on them. Say, for instance, they take a Corona charger at the factory and put what we call a supercharge on it. The problem we have that we found with that, especially here in Florida, it's even more prevalent, is there's 3 basic ways that you lose your charge on a filter. So 3 different ways is we have humidity in the air, moisture in the air, we're bringing in outside air. Well, we have that. So you're discharging the filter that way. Also, when you're starting to load particulate onto the filter fiber, you're starting to insulate that fiber. So think of plugging a lamp cord in and it has nothing around it but bare wire, and you grab it, you're going to get shocked, right? If we insulate it with rubber or plastic, there's no transfer. So basic same thing happens to a charged fiber when it starts to get insulated by particles. And the third way is, in the air is certain amounts of alcohol and things produced from kerosene from planes, trains and buses use diesel, and especially if you're in more of a downtown type area or a crowded area, lots of cars. An airport's probably a great example where a filter would get discharged probably in a couple of minutes with planes sitting out there. What happens is when you lose that charge, you're losing your efficiency. We really promote what we call fine fiber medias, which the fibers are a lot smaller in diameter, and there's more of them put together in this filter matrix. And another important thing is the amount of loft or thickness of the media. You can take a lot of really good quality pleats and tear them apart and look at the side of the filter, and you can see how much loft is in the media. And you can look at some cheap ones and you'll see it's about as thin as a piece of paper or 2. So it's not going to hold any dirt. It might even stop some dirt, but it's going to have a shorter life that way.
Defining some terms here. So when we say efficiency, we're talking in terms of MERV, and that's how well it captures particles. When we talk about the size of the fiber, you're talking about how thick or thin the fibers are themselves. And when you're talking about loft, you're talking about the thickness. If you were to look at the cross-section of the media, you were to take a piece out and look at it. And those are all big factors. And then you also mentioned surface area itself. And it's something interesting that you pointed out to me that I had never thought of before. You had showed me 2 different 2-inch filters, and that one had a significantly increased number of pleats in it based on the others. So can you talk about that?
You'll see out there 8 pleats per foot, 10 pleats per foot, 15 pleats per foot. I've seen 12 pleats per foot. When we take media out of the media, I call them deleted pleats.
Right.
Basically, it makes the filter's initial cost cheaper. But really, when you're purchasing filters, you do not want to look at initial cost. You want to look at annual cost, and you want to look at your TCO, or your total cost of ownership. In other words, if we're using a cheaper filter, let's say a $5 pleat, and we're having to change it every 3 months because of the cheaper media and the cheaper configuration and so on and so forth. So you're changing 4 times a year. So if you look at that total, and then you look at a filter, let's say that's $8, but is a lot better quality, and you only have to change twice a year, you're actually going to save on material costs for a better filter annually if you look at the annual cost and the associated. So when we have a filter with more media and so on and so forth, more surface area, again, remember, going back to the straw thing, so we're going to last longer, we're going to have a lower resistance or a lower pressure drop over time for the 6 months and then the year. So we basically just cut the labor in half. We just cut the disposal costs in half. It's a much greener option when you're changing twice a year than 4 times a year, with basically the same amount of cardboard and so on and so forth. So it's a much better option that way.
A couple quick things I want to talk to you about. One of them is the UEI Hub Smart Kit that was designed by my friend Adolfo Wirtz. You can hear more about that in the podcast Probes versus Manifolds. But about this probe set, it's a really well designed set, and among the things that I really like about it is the 1/4-inch air probe. You know, a lot of the other air probes, the temperature and humidity probes that go into the airstream, they're larger, and so that makes making the holes a little bigger, especially where I am in a duckboard market. If you ever have to work with duckboard, it's much easier to deal with a smaller penetration than it is a large one. You start getting out a bigger drill bit, and it makes a big mess of the duckboard, and that's been a real problem for me over the years. And so the Hub 2 kit is the 2 air probes, and I really, really like that feature. And another thing that I really like is how well the Bluetooth works, just how easily it connects and disconnects. And, you just turn them on. In fact, even with the AirProbes, you just open them up and they lock at 90 degrees and boom, it just works. And they've got nice, strong magnets on the base. Just a well-designed instrument. So if you're in the market, I would encourage you to take a look at the UEI probe kit, the Hub probe kit. You can find out more by going to ueitest.com. And another thing, when we're talking about really well-designed products, I'm going to talk to you more about Refrigeration Technologies. I've enjoyed Refrigeration Technologies products for many years. I've been using Nylog for many years, and I was always impressed by that product. I remember I could go right now to the first job that I used Nylog on. It was a grocery store, and it was we had to do a major compressor replacement, a semi-hermetic compressor replacement. And we had all these threaded connections that we had to make, and I picked up Nylog and used it, and I just thought it was great. It really worked great for that job, and I've used it ever since. And that's been many years ago. So obviously, a lot of you have used Nylog. A lot of you like it. But I would also encourage you to look at their Wet Rag product, which is a product that you can wrap around valves, expansion valves, service valves, place in front of dryers. So that way, you simultaneously don't damage the internal components of them because it helps pull the heat away. But then it also helps prevent from burning the paint, because you don't want to burn the paint on, say, an accumulator or a compressor or a line dryer, because then later on that can lead to corrosion, rust, and then leaking. So I think it's a really great product. A lot of you still like to use old school wet rags, and that's fine, but a typical wet rag is not going to have the heat absorbing capacity of this wet rag product made by Refrigeration Technologies. And it's a real easy product to use. You can reuse it. You can add a few drops of water to it, and it rehydrates it. Just a very, very nice product, and everything that Refrigeration Technologies makes, in my experience, everything I've touched is just really good products. And you can find out more about Refrigeration Technologies by going to refrigetech.com. That's refrigetech.com. REFRIG tech.com. You can find all the products made by Refrigeration Technologies at TruTech Tools, TRUTechTools.com, and you can get a great discount by using the offer code GETSCHOOL to check out. I had someone tell me the other day, and this is the first time I'd ever heard this. They said, our electrostatic, and they're talking about a disposable type filter, our electrostatic regenerates itself based on the air flowing over the air filter. Is that something that you've ever heard of or you're familiar with?
I've heard a few things relating to that, and I don't know how that could actually even happen, especially being here in Florida. It's going to be even more prevalent, to where when you're bringing in outside air, you're bringing in humid air, and you're going to be hitting that filter with that. Again, when you're loading particulate onto the filter, now if that filter stays clean and you're cleaning that all the time, and that's hugely labor intensive, if it's what we call a permanent electrostatic filter, which basically those were popular in the 60s and 70s, I couldn't even sit here and tell you of an account that's used any of that kind of technology for many, many years.
Right.
I really don't know how that could happen, but
who knows, right?
Things happen.
It makes sense what you said there, though, that if you have a higher relative humidity air, it's much less likely that there would be a static electrical charge generated, because you would have more conductance in the air. It's just the same reason why you have electrostatic charges. You shock yourself on the door, and when it's very, very dry out, maybe there might be more to that in a really dry environment. But of course, with us in Florida,
well, again, when you're loading particulate onto the surface of the filter, you're going to insulate any charge that's on that.
Yep, good point. So let's talk about that MERV 8A, because MERV 8 is what we're all used to. You go to, down here we have Publix, that's our grocery store. All the homeowners go to Publix or they go to Walmart and they buy a MERV 8 filter by whoever. And if they read the fine print, it'll say MERV 8 and not MERV 8A. So what is the difference?
Earlier, we talked a little bit about what's happening to filters, right? We're finding MERV 8 pleated filters that are dropping to MERV 5 or 6, right? So after some investigation, we are finding that, well, these filters were charged and they're losing their static charge. We started looking at, and then ASHRAE got a hold of it and ran with it and started looking at it and did a lot of, testing and so on. They ended up coming up with a new test. So the MERV test is called, the standard is actually ASHRAE standard 52.1, and that's the old dust spot test. Then you have the MERV test was 52.2, and then you have the 52.2J, which is the MERV A or addendum part of the test. And basically what that does is kind of pulls the pants down a little bit on charged filters and what happens to charged filters. And even ASHRAE saw that there was issues with charged filters dropping in efficiency. Basically, what they do is they run the MERV test, and then they run another MERV test using potassium chloride. It's like an alcohol type product that will remove a charge off of a surface. So they're basically in the lab showing you kind of what happens to charged filters when they lose their charge. The interesting thing is even in the addendum and all that, they tell you that in the field is probably even going to be a worse charge loss than they get with lab results. Even ASHRAE tells you that. The problem that we have is you're purchasing a MERV 8 filter, and it's a MERV 8 when you put it in. And as time goes on, sometimes it's days or a week or two, you're losing that charge. And now you're down to MERV 5. So you didn't really get the filtration that you paid for. And that might be specified. Like if you're a hospital or anything, healthcare, that's places where you really can't afford to mess up.
If we talk about MERV 8 and MERV 8A, do you also see that same effect in the higher MERV ratings, like MERV 14s, that sort of thing?
Yes.
So a lot of them are getting a MERV 14 by applying an electrostatic charge then.
We actually look a little more when we get into the higher end filters. We put a lot more emphasis on the 0.4 micron size particles, because when we're getting to, let's say, healthcare, we're getting into places that are a little more critical with MERV 14 filtration, we want to make sure that that's what we have, okay? So we can't afford to mess up there.
Right. Can't afford to be wrong.
Right. The biggest issues that we have, and that drops that I've seen, are MERV 10, MERV 11, that MERV 14s turn into. When we're looking at 0.4 micron, typically we should be around 60 to 70-ish% in catching those. And a lot of the electrostatically enhanced medias that I've seen, the coarse, large fiber medias, are around 35, 40% at 0.4, which is a critical, I guess, size.
Right.
So that's issues with us. And that's why we won't even sell that type of product to healthcare or NASA or things like that, because we don't want to be responsible for things happening that are bad.
Right. You don't want to have that come
or
back.
a product not doing what it's supposed to do. And that's why you really need fine fibers to do that,
Right.
to stop smaller stuff. The technology may change, and it is changing, and something may happen with electrostatic medias or what have you, where they're better, so on and so forth. To this point, I haven't seen it yet. At this point, I'm sticking by my guns with fine fiber.
Got it. Right. Fine fiber. And essentially, I mean, what it comes down to is just good, solid, well-manufactured filter. I mean, it's kind of an old school ethos. Make it well, make sure that the fibers themselves are well designed and that you have plenty of surface area. Because when you talk about the number of pleats, I mean, that's essentially what you're saying. If you're deleting pleats, a delete-a-pleat, as you called it, if you're deleting pleats out of a filter, then you have less surface area. And if you have less surface area, then you don't have as much capture media, and you are going to have more issues with increased static pressure because you don't have as much surface area. It's going to load more quickly. Another thing you had mentioned to me was the idea that some of the less quality air filters, when you do testing, because, and this is the first time we've mentioned this, but Camfil is a company that you do a lot of work with. They do very thorough testing. And you were saying that on some of the less expensive media, you'll actually see that the static pressure stops increasing because what's happening is particles are just going in one side and just pulling right out the other side. Could you go into that a little bit?
There was actually a college in Florida. We did some testing, and we didn't even really do the test. The electrostatic, I guess, filter company ran the test.
Okay.
I kind of found out about it later, but then I was brought in to look at the test. And basically we had fine fiber type medias. It was a brand new building, had 2 identical air handlers. So it was a good place to test. They're servicing the same area. One had our filtration in it that's fine fiber, and the other one had electrostatically enhanced filter. The electrostatically enhanced filter, kind of to get down to the nuts and bolts, when I went in, it had been in there about a year and a half. It was a 2-inch, what we call a mini pleat. It was basically black on both sides, front and back. If you looked at it, you would say, there's no way this could get any blacker, okay?
Right.
And the pressure drop on the filter was reading that it was still about half done. And they had already had to change our product after a year. And basically what happened was, I'll use this little example. If you take a glass, 8-ounce glass, you got a gallon of water, you start filling that glass. When it gets to the top, it's going to overflow, and that's it. It's all it can hold. That was basically our filter. What we discovered was what was happening with the electrostatic filter is, so I saw pressure drop readings, and they were reading like 1/2 inch of pressure drop or resistance, and then it would drop the next week to 0.35, and then it would go up to 5.8, and then it would go to 4.5. So what was happening is this filter was just loading, and then could only hold so much dirt. Because it had coarse, large fibers, it would just let a lot of particles through.
Right.
And so it was basically loading, unloading. The selling factor to those people, that customer, was actually, he took me up and we looked at both units, and downstream of the coil, they had lights and they turned on the light and there was a port window. He showed me my unit. He says, look, nice and clean, windows nice and clean. We went to the other unit with electrostatic filter and there was all this dust all over the window. He was like, this was one of the factors that this filter seemed like it was going to last 10 years, and it was just unloading, loading,
Right.
unloading.
Right. That's the efficiency of the filter as it loads. Does that filter keep catching as it's loaded, or does it just start unloading? And like you said, that's proof positive by the fact that the static pressure didn't keep increasing. I guess it's sort of like every filter that's doing its job, the static pressure should continue. If you look at that curve, it should just keep going up and up and up as the life of that filter goes, because that means that it's not releasing particles back into the airstream.
Yes, and it may vary a little bit, but over time it should continue to go up,
Right.
to a certain point.
Right, obviously.
And
at some
manufacturer's
point,
going to tell you what your change out point for be. Most MERV 8 pleats and that 2-inch pleated filters and such are typically about 0.90 to 1 inch of static pressure drop if you looked at an air pressure gauge on the unit. So your final filters, a lot of those will go to about 1.5 or 1.5 inches of pressure drop before they have to be changed.
Right. And obviously, just a quick disclaimer here, because some of you are listening who are thinking like residential. And residential, if we have 1 inch of pressure drop just across the air filter, we're in big trouble.
Yeah.
So we're not talking about residential here. We're talking about generally systems that can handle much more than that and are designed to, VAV systems, that sort of thing. But the point is that these filters can handle that, meaning that they're actually physically designed to handle it. Unlike another factor, and you showed me this, is that there's a huge difference also between the structural integrity of a good quality filter, like a lot of the cam fills that you were showing me, versus the less expensive options as well.
Yeah. So when you're looking at a filter, it's going to have less media and things. So already right off the bat, the thought is, well, how can we make this cheaper?
Right.
Okay. Initial cost. Well, guess what else they're going to do? The cardboard grade is going to be cheaper. So a lot of the cardboard grades out there are anywhere from 18 to 22 gauge cardboard. Might see some 24 gauge cardboard sprinkled in. So the higher you go in the gauge of the cardboard, that's the thickness of the board, the heavier it's going to be. And so a lot of those are also made out of recycled materials, which we feel is a good thing, but in air filtration, it's not really too good of a thing. When we look at like Camfil tape meet cardboards, they're going to be using virgin cardboard and 28 gauge board. So we've got a heavier board. And the difference between recycled board and, let's say, virgin cardboard is, if you know what OSB is, you don't want your roof really made out of that because it's particle board. You want your roof made out of plywood. So the same thing applies with the filter cardboard grades and what they're made out of. When you start adding moisture in the units, we have that. So you're going to start swelling that cardboard and weakening that cardboard because it has a lot of glue in it. The other thing you want to be concerned about is what type of backing is in the filter. Basically, there's 3 types of backings. There's what we call a self-supported plate that doesn't even have a backing. They make the media, they add some rigidity to the media. I always see those sucked in. Okay. Right. And then you'll have what we call expanded metal. Looks like the little diamond things that's applied to the back of the media. And it's basically made out of tin. And you can kind of take your pinky finger and just push down on it, it'll collapse. A good test is if you, say, set a cheap filter down on a table, flat table, just take the palm of your hand and kind of press down on it and put a little pressure on it. You'll find that you're going to crush those expanded metal plates pretty easily. So like in the Camfil product, we use welded wire, and it's 100,000 pound tensile strength, so it's really strong. You can do that same palm test with that Camfil filter. You're going to see a difference. When you pick up the filter, you're going to feel a difference. It's going to feel a lot heavier and a lot more robust. So it can hold up to the moisture and the high pressure drops that we might have. So structure is really important, because if you have a filter sucked in.
Right, and it's not doing its job. Yeah.
Yeah.
Yeah, how many of us have seen that, right? Now, I guess the challenge that a lot of people may be thinking, and it's a challenge that I face too, it's kind of like, but how do you get a customer's head around the benefits of improved filtration? How do you have that conversation? Do you have any tips for that?
Basically, doing a TCO, or total cost of ownership, is your best way. Because if you show them that you can provide them with a superior built filter, so its structure is better, it's got fine fiber in it, and all the aspects of the filter, versus a cheap initial cost filter or first cost filter. Again, when you do the math and then you add the energy savings to it, because we're going to have a lower overall pressure drop for the year, the energy savings is probably about as big as any of it. I mean, just alone that. So we're all thinking about light bulbs and all that kind of thing, right? LED, and how do we save water and things?
Right.
But the air filtration is hidden off in some air handler room, behind closed doors, inside a locked up air handler. So a lot of people aren't really thinking about that. Light bulbs, we're looking at those every day, go, wow, I wonder how much energy they use. But your HVAC systems are using 40, 50% of your building's electrical costs. And then depending on the filter design and how it's built, how efficient it is, that can be another 35, 40% savings, a really good filter over a poor filter. We talk $5 for a cheap pleat and $8 for a good pleat or whatever. I mean, the better pleat alone in energy savings can be $13, $14, $15 a year just for one hole. So you think if you have 100 holes, that's a lot of money just in the energy savings. And then all the sustainability aspects of it too. So
people who are concerned with the environment, you're filling less landfills. If you actually go to a significantly better filter than what they had before, in some cases on the high-end facility side, you can actually reduce the number of trips and to get the same job done with fewer filter changes. And so there's other things you can look at as well there. But I think you make a good point, because you look at the efficiency based on the reduced pressure drop, but then also think about the efficiency of the equipment over time, because it's not getting as dirty. You don't have as many problems with that. Add in the fact that with a better filter, better capture, better efficiency over the entire life of that filter, you're also going to have better indoor air quality, which that's one thing I've been thinking a lot about. Even for those of us who do residential, I think that's probably the easiest sell in the residential market is, at this point, this is the filter rack you have. And so would you rather go with an inexpensive filter that risks collapsing, it's going to have more bypass because of that, isn't going to do the job over its life cycle? Or would you rather go with a MERV 8A filter? We're talking in this case about 1-inch residential, that is going to do a much better job of both maintaining the equipment, but then also keeping your air clean.
So look on the side of your filter that you're purchasing and see if it lists the MERV rating and also the MERV A rating. That's an important thing, because a lot of electrostatically charged or cheaper grade filters, a lot of times they're not going to have the MERV 8A or what have you, or the A rated on the side of it. So it's a good thing to look for when you're purchasing filters, is that number.
And on some filters, I know they'll actually have like the piece of paper that's stuck to it, the consumer grade. Some of them will actually even kind of tell you that it's an initial efficiency and that the efficiency does drop. There's actually, I don't know where I saw that at. It was from a popular filter manufacturer. They had a little piece on that basically described just that thing, that their efficiency can drop after that initial usage. It was something, they use very ambiguous language, like at some point the electrostatic charge can be depleted and it will be a MERV 6 now instead of a MERV 8.
Yeah, and they will do that, especially some of the large companies have lawyers. So that might be a little bit of a disclaimer on, we're telling you, yes, it's a MERV 11, but it really corresponds to a MERV 8.
Right.
Is it a MERV 11 or a MERV 8? Yes.
Depends on when you measure, right?
Yeah.
Another kind of just general encouragement that I kind of came away with from my first meeting with Lee was that filtration is still one of the most overlooked elements of the HVAC technicians and the HVAC sales cycle and ownership. They're one of the things that's the least considered, which is kind of ironic given that it's one of the more critical pieces that we deal with. I mean, how many bogus service calls do we get where you show up and somebody just has a dirty air filter? So it's always top of mind, yet we don't think carefully about the products that we're choosing. Even thinking not only about choosing one type of 1-inch filter over another, for example, or 2-inch filter, but thinking about going up in size and in surface area in order to do a better job. What encouragements do you have to the average AC contractor out there who's going about his merry way and maybe hasn't been thinking much about filtration in the past? How would you encourage them to think about this?
I've been in the industry for 30-something years, and I know on the HVAC side how they make their money and so on and so forth. And you can, I believe, provide a better service to your customers and build that trust and honesty that maybe your customer's looking for to say, hey, you can go to this better quality filter. It's going to save you money annually. I might not be here as much. I'm probably going to be here doing my quarterlies and everything anyways, but we can skip that filter change and we can actually run a little bit longer and save you money in other ways, like the energy side and so on and so forth. All cam filter distributors like myself actually have total cost of ownership software. It's called LCC, where we can actually take the building or all the units or what have you, plug in the filters that they use, even competitive filters or whatever, and compare filters, which is kind of interesting because it gives the end user a total cost of ownership. When you present that and they see all the advantages and everything, they say, wow, that really makes an impact. And we really didn't think of the energy side and things like that. We're probably selling filtration almost more on energy now than almost anything else because so many people are so into that. I also wanted to mention too, real quick. So we're also looking a lot more at the health side of it, more than ever. Europe just adopted a new, I guess the MERV and all that is kind of going to go away. Europe was EN 779 was their MERV. They just adopted the ISO 16890 standard. The US is looking at it very hard. They're trying to make it one test globally. It's basically going to look at particle sizes and particles that are related to human health. So they're actually going by the World Health Organization standards. So the new test, I believe it's going to happen, is going to be even more stringent than the MERV A. And it's going to be a good thing because it's going to be easier for you all to be able to pick out what filter you need for what situation also. So we're actually going to be looking at cities. Are you in the country? There's all kinds of things that are going to be added to it. It's going to be a really neat test. I think it's really going to be updated. So kind of film at 11 on that. It's in the pipe right now with ASHRAE. So we'll see what happens.
Very cool. So you function in the state of Florida, right? So Andrews Filter sells throughout the state of Florida. So for people who might be in the state of Florida who are thinking, gosh, I'd rather maybe work with somebody who actually knows filters, what would be a good way for them to find out more about your business and then maybe a little bit more about CamFil as well?
Well, our website is good. It's www.andrewsfilter.com. On there is all our contact information, and there's some cool links and study things, and you can find out a little bit more about us and maybe a little better quality filtration that you might not have heard of, and some things that might interest you and get you thinking about other things than what you're used to thinking about in filtration, like energy and things like that, and sustainability.
Anything I'm missing here? Anything that everybody needs to know about that I've forgotten to mention?
I think we covered some good things. There's a lot in air filtration, and we could go on for hours and hours and hours. Maybe we'll do it again come up with some other good things, but I enjoyed my time, and I hope that we might have helped some people, and we can always help answer some questions or whatever if you have those too.
I'll share Lee's personal cell phone number with all of you later while he's not here sitting here, and then you can just call him up at all hours of the night like you do me. So
that'd be great.
All right, I appreciate it, Lee. Thank you.
Thank you.
Hey, big thanks to Lee Andrews for coming on the podcast. Very nice guy. I enjoyed sitting down with him at his office here in Orlando and talking air filters. So thanks to Lee. And another thing I want to mention real quick, I'm going to talk about this in some future episodes as well, but one of the biggest questions I get from business owners or managers of businesses is how we find employees at Kalos. And the fact is that generally we train our own people. Usually we don't hire a lot of experienced people because generally the market isn't, in my experience, isn't real great for experienced people. But I talked to Patrick Long, and you may see Patrick in the groups, and he has a new service for recruiting where he leverages social media specifically, and it's called BizPal. So if you go to bizpal.org, you can look up what Patrick and what he's doing, and it's pretty innovative. He's got a really nice system. It's very smooth. You go through, answer a bunch of questions. You have to have a Facebook page for your business. Give him access to that. There's a couple little steps, but he makes it really easy. And we've gotten a lot of good applicants. I mean, I've gotten, I think, 12 qualified applicants. We've gone through them, but we actually just made an offer to someone today, and he accepted. So we are going to have a technician who works at Kalos because of what Patrick did with BizPal, and I would encourage you to check it out at bizpal.org. Also, I want to mention WriteSoft. WriteSoft, load calculation software, duct design software, all that. If you listen back to my Jack Rise episodes, Jack's a huge fan of WriteSoft. I'm a big fan of WriteSoft. If you're in the market for anything like that, anything in the design side of the business, then I would encourage you to look at WriteSoft. So the other day I went to the doctor and I was having some abdominal pain. I have a lot of kidney stones, and the doctor said, Brian, I've got bad news for you. And I said, what? He said, well, you're colorblind. And I said, Doc, don't hit me with something like that right out of the orange. All right. Thanks for listening. We will talk to you next time on the HVAC School Podcast.